Okay, today we're going to talk about mechanics of machines. So the first thing I want you to think about is a little machine. So let's devise a machine. Okay, so in this machine here, so inside this machine, when you press on the left side here, this is called your force of your effort. Okay, when you press on that, the right side, which has a weight, will go up. Alright, so this is the direction. It's called the force of the load. Okay, and as this device goes up, let's just imagine that it goes up to here. Okay. So as it moves up and as you press your hand down, it goes a distance. So this distance is commonly known as S. So S of the load. So distance of the load. Okay, the distance that you push your hand down, that one is the S of the effort. Okay? So in this machine, if you were to raise this load 100 millimeters, but you had to lower the load, you had to use your hand to push down on the lever 1200 millimeters. Okay, so if you push down 1200 millimeters, it would raise the load 100 millimeters. This is called a velocity ratio, which is equal to the distance of the effort over the distance of the load. So, in this example, that would be equal to 1200 millimeters over 100. So this is equal to 12. That means that for every 12 units that you push down by the effort, it goes up 1 unit in the load. So you push down 1200 millimeters in the effort, it goes up 100 millimeters in the load. Now, if this load was 450 newtons and your effort is 50 newtons, okay, we can call this the mechanical advantage. That means that you've pushed down with 50 newtons of force to raise a 450 newton weight. Okay, so that's called mechanical advantage, is equal to the force of the load over the force of the effort. Okay, so that is equal to 450 newtons over 50 newtons. All right, so if we divide those two, we get 9. Now there's another important factor. So what's happening here is you've had to push down on the object, I guess on the lever, 1200 millimeters to raise a load 100 millimeters high. So basically you are raising a heavy load a small distance. And as a consequence, you have to push a very far distance for that to happen. That's what this machine does. So let's look at the next object. This is called efficiency. So efficiency is represented by the letter N. And it's equal to mechanical advantage over the velocity ratio. So this is equal to 9 over 12 in this example, which is the same thing as 75%. Okay, 0.75. Now if we multiply that by 100, that will give us it in percentage, so 75%. So what it's saying here is that 75% of your effort as put in is being converted to raise a load. So 75% of your effort will raise the load, which means that the rest of the 25% remaining fights against friction. Okay? So, how do we know what would be the ideal, it's called the ideal mechanical advantage. What is the ideal amount of effort required to raise this load if there's no friction. So ideal mechanical advantage is equal to the velocity ratio. Okay? So that means that the object is 100% efficient. So here's how you can test it out. So take your load. So we have the force of the load is equal to 450 newtons. Okay? And if we divide that by the velocity ratio, which is 12, okay, then we get the ideal effort would be 450 divided by 12, okay, and we can calculate that. So I'll calculate that real quick. Our ideal effort is 450 divided by 12. So it should really only take us 37.5 newtons of force to raise the load. Okay? Finally, if it really took me 50 newtons to raise the load, but the ideal force is 37.5 newtons, that means that friction is the remaining effort. So 50 take 37.5. So 12 newtons friction is equal to 12 newtons. So this kind of concludes the first part. Let's look at the second part.